All right, core concepts, horizontal transformations. All right, quick reminder, remember everything inside the parentheses is x and backwards. Outside the parentheses is y and normal. All right, so everything up and down is outside, everything left and right is inside. Just a quick reminder. All right, so your horizontal transformations. If I got f of x equals x squared, if I do f of x minus h, well, that's going to be x minus h squared. Okay? So if I make the transformation, if I subtract whatever value h, that's what's going to happen inside the parentheses. That's where we get that vertex form of f of x equals a x minus h squared plus k that we talked about during the vocab. All right? So to go left is when y, I'll do it in a different color so life's a little bit simpler. If y equals x minus h squared and h is less than 0. So if like h is negative 3, okay, it's going to go left. Now remember, the way it actually looks, it's opposite because of that negative in there. The equation will, if you're going left 3, the equation will actually look like y equals x plus 3 squared. This is actually x minus negative 3. That is the h value in there. Okay? So because of this negative, which is part of the equation, it's going to flip it. Alright? If I do y equals x minus h squared and h is positive, so h is greater than 0, it's going to shift to the right. Alright? So, it shifts left when h is less than 0, and it shifts right when h is greater than 0. Alright? And I'll put over here, don't forget to flip it. You have to flip it. Flip it good. Alright, there we go. Clear as mud? Perfect. Alright, let's switch to the next one. Pause. Your vertical translations. Again, everything inside is x is backwards. Everything outside is y and normal. Inside x backwards, outside y and normal. Inside x backwards, and outside y and normal. So if I've got f of x, and I do plus k on the outside, I'm going to have an x squared. I'm going to have a plus k out here, outside of that squared region. Again, that's when we have the equation f of x equals a x minus h squared plus k. So we're talking about what does this plus k out here do. Okay? So, if I have y equals x squared plus k, and k is greater than 0, so if we're adding something to it, that would be this interior line. We took the dark black line and shifted it up. Okay? It goes up. Okay? If we have y equals x squared plus k, and k is less than 0, so the effect is you're actually subtracting something, that would be this one outside. We shifted it down. Okay? So, it shifts down when k is less than 0, and it shifts up when k is greater than 0. And just like the h, we flipped it. This is do not flip. Okay? Because everything inside is x and backwards. Everything outside is y and normal. This is outside, okay? So you do exactly what it says. All right, let's keep rolling. All right, reflections. Reflection in the x-axis, reflection in the y-axis. All right, so if it's a reflection in the x-axis, remember that is an outside transformation. That the reflections feel backwards. Because to go across the x-axis, like that, is a vertical thing. So if the f of x is negative, you have a negative x squared. Alright? So if this is your original, y equals x squared, this is your new one, y equals negative x squared. Okay? That's that one right there. Reflection in the y-axis. Okay, a reflection in the y-axis is actually an internal thing, because to reflect across the y, alright, you have to go left and right. So if I do f of negative x inside the parentheses, it would be negative x squared. Now, this is one of those where this is actually kind of a poor example. Alright, so because if I take this point and reflect it, it goes over there. On the same idea, if I take that point, I reflect it, it goes over there. So it's the exact same graph. Alright, so y of x squared is actually the same graph as y equals negative x squared. So let me give you a better example, okay, real fast. So if I go like this, if I have some graph, this is some quadratic graph, okay? We'll say this is f of x right there. If I do f of negative x, alright, all of those points over there reflect across, let's do a little better than that. Reflect across the x-axis like that. So all of these points, this one switched over to there, this one switched over to there, this point switched, oh stop it, this point moved over there, okay? It's just perfect mirror imaged. Okay? Let's move on to the stretches and shrinkings. Okay, horizontal stretches and shrinks. Horizontal stretches and shrinks. Alright, so if I'm horizontal, okay, remember horizontal is a fancy term for, come on, stop it. Is a fancy term for left and right. So that would be an inside thing. Horizontal stretches and shrinks, that's when I multiply the inside by some value of a. Okay? So this would be a of x inside the squared region. Alright? And remember, everything inside is x and backwards. So if the darker one is the original, so let's say the red one is the original. Oh, let's take common. Let's say the blue one is the original. Okay? If I do f of a of x, okay? Oh, let's write that differently. Let's stay consistent. Y equals a of x squared, and a is greater than 1, okay? Remember, everything is backwards. So if you're like multiplying by 2, you're really dividing by 2. So it's this one right here. That is actually a shrink. Okay? This is actually a shrink. That's if it's greater than 1. If you do, let's see here, let's pick this color. If you do y equals a times x squared, and a is, this is where you have to be a little more specific. A is bigger than 0, I'm sorry, but less than 1. It's actually a stretch. So we're talking about some sort of decimal. So like, 0.2 or fraction 1/3, something along those lines. That would be a stretch. And the reason it's greater than 0 is because the number does one thing, the negative does something else. Remember the reflections we just did, those negatives reflected, but the actual number you're multiplying by, whether it be positive or negative, that stretches and shrinks. So this would actually be a horizontal stretch. So it's a horizontal stretch, quotes, away from the y-axis, when you're between 0 and 1. It's a horizontal shrink, it comes towards the y-axis when a is greater than 1. So 2, 3, 4, 5, 6, 7, and 8, all that sort of stuff. Okay? Vertical stretches and shrinks, same idea. So this time we are multiplying the outside, so it's a times f of x. Or in other words, it's going to be a of x, a times x squared. It's not inside the squared region. It's not inside the parentheses. You got to put parentheses in there. The parentheses are really kind of like right there. So it's outside the parentheses. So again, here's your original. What happened is, if I take y equals a times x squared, and a is greater than 1, alright, it's actually this guy right here, because you are taking all of these points and stretching them upwards. Okay? It's like you're taking it like a rubber band, you're stretching it up. If you do y equals a times x squared, and a is between 0 and 1, it's actually a vertical shrink. So it would be that one right there. And you're taking all those original points and you're shifting them down. All right? And now at this point you may look at that and say, well, what's the difference between the graph on the left and the graph on the right? Well, honestly, you can get the same thing done with a horizontal stretch or a vertical stretch. But the numbers will be slightly different and the way you deal with it's different. So it really depends on where are you applying that number. Are you applying it inside the parentheses like over there, or are you applying it outside the parentheses as to where it is technically a horizontal stretch and shrink or a vertical stretch and shrink? Okay? So yeah, they do look similar. Alright, last but not least, vertical stretch. Again, away from that x-axis, you're stretching upwards when a is greater than 1. And it's a vertical shrink. You're basically squishing it down towards the x-axis when you're multiplying by something that's a decimal or a fraction. So, or should I say a non-improper fraction. So 0 less than a less than 1. A is between 0 and 1. All right? And that's it.